Hello class. Here we're going to look at an example, the elevator problem, and we're going to apply Newton's second law to look at the tension and the acceleration here. So we have a 740 kilogram elevator, accelerates up at 1.1 meters per second squared. What is the tension in the cable lifting it? We can see that we have an upward acceleration, so it says it's upwards. We're defining that then as our positive y. And we've got a positive acceleration. The free body diagram is shown. We're going to have the tension from this cable lifting the elevator upward, and we've got the force of gravity acting downward. And I'll note that I usually put this as an Fg, because I find sometimes it gets mistaken then for a separate little g to multiply it by 9.8. We're going to look at the sum of the forces here, and Newton's second law says then that we will have an acceleration that is proportional to that force, that net force. Our upward force is the tension, and we have a downward force of negative mg. And that's what's providing the acceleration. And so this is telling us that the tension then, if we rewrite it, is just the weight plus a term ma. And so that's saying that the tension is increased by the need to accelerate upward. It's more than just the weight of the elevator. It has an additional value or an increased value because of the need to accelerate upward. And so it's very simple then to substitute in those values. 740 kilogram mass times 9.8 meters per second squared plus the 1.1 meters per second squared in the upward direction. And so the tension now has 8,100 kilogram meters per second squared, or in other words, 8,100 newtons. So again, emphasizing that the tension is increased by that need to accelerate upward. It'll be larger. If the elevator is not accelerating, then that whole term goes to zero, and we're just left with the weight. So the tension is supporting the weight of the elevator. If the elevator is accelerating downwards, that AY in above is negative. And so now T, or tension, is less than the weight of the elevator. So the tension is letting gravity win a bit. What if the elevator is moving at a constant speed, up or down? You're then saying that the sum of the forces, Newton's second law is mass times acceleration. If it's going at a constant speed, our acceleration is equal to zero. In other words, the sum of the forces must be equal to zero. And that's just what we said up above, that the acceleration was equal to zero. So we're saying the same thing if it's moving at a constant speed up or down. It's at rest or moving at a constant speed means the acceleration is equal to zero. I'll leave you with one more thought. Think about the woman in the elevator. What are the forces on her, and how do they change with upward or downward acceleration? In particular, think about the normal force that's acting upward. Does it increase or decrease, or stay the same, as the elevator is accelerating upward or downward? You'll see that we have very similar concept there as the tension problem here.